Well, hello, everyone. I think we can get started now. My name is Victoria Alonso Perez. I am the founder of ChipSafer, which is a startup where we monitor livestock remotely. And I would like to welcome you to this masterclass together with the World Food Forum. And as you know, a lot has been talked about livestock and especially about the meat industry, especially around the subjects of sustainability, nutrition, and innovation. But out of all that has been talked about, what is the actual truth? And so in this panel, we're going to talk a lot about the myth and what is behind everything and about the really sustainable production systems for livestock production. And in the past days, we have decided to do a poll to see on the social media how the public thinks about the meat industry. And so if we can put the slide of what the results were. As you can see here in the social media survey, we asked the followers about if the beef production industry has a bigger climate impact than the energy industry, and 62% said yes. All beef farming necessarily harms the environment. 41% said yes. Synthetic meat is more environmentally friendly than farmed meat. And here we are kind of tie to tie, but still 48% said yes. Humans do not need to consume meat. And here we also have a lot more for yes than no, with 71%. And in grazing production systems are always low-tech systems. In this case, only 30% said that was correct. And now to see if these claims are true or not, we will go through them through our panel. And so I would like to introduce Dr. Laura Astigarraga, who will start with her presentation on the grazing systems, the sustainability, and the protection of biodiversity too through this type of ecosystems. So Laura, I give the word to you.
Okay, thank you, Victoria. Can you see my screen now?
Yes, perfect.
Okay. Okay. First of all, I will like to thank the organizers. I'm really honored to participate in the masterclass. And in this presentation, I will try to explain the unique role ruminants play in our planet to contribute to food security. Like other agricultural systems, livestock system can impact on the environment. And the Food and Agriculture Organization estimates that the livestock sector as a whole contributes almost the 15% of total anthropogenic greenhouse gases emissions. And beef and milk production make up the majority of this. Emissions associated with large ruminants are primarily related to land use changes, such as deforestation, pasture management, manure management, and the most important, enteric fermentation. When it comes to tackling climate change, the focus tends to be on clean energy solution, as energy accounts for the majority of greenhouse gas emissions. But the global food system, which encompasses production and post-farm process, such as processing and distribution, is also a key contributor to emissions. Why is methane important? Methane, as a greenhouse gas, is a tiny fraction of our atmosphere, but in the first 20 years after release, methane is around 80 times more powerful than carbon dioxide and trapping heat. On the other hand, it also breaks down much more quickly than carbon dioxide, with an average lifetime of around a decade compared with centuries of carbon dioxide. As COP26 highlight, this means that curbing methane emissions could provide short-term relief while governments negotiate the more difficult transition from fossil fuels to clean energy. What is enteric methane? Plant cell walls cannot be degraded by mammalian enzymes, which is why humans cannot effectively use grass as food. Ruminants are uniquely adapted mammals that can use plant cell wall as a major source of energy because of the microbial fermentation in one of their stomachs, the rumen. Methane is generated by anaerobic fermentation, where bacteria break down organic matter producing hydrogen, carbon dioxide, and methane. And then the methane is burped and released in the atmosphere. Because of this evolution, ruminants are able to utilize forages, agro-industrial byproducts, crop residues, and convert them into high-quality products. These characteristics give ruminants a role in food security. They supply 50% of all protein from the livestock sector, and for many populations, livestock is a primary source of nutrition and not a simple source of calories. Livestock provide increased economic stability to the farm and household, acting as a cash buffer and as a capital reserve. However, critics of animal production have argued we should be feeding human edible foodstuff to only humans and not include this in ruminant diets. The global livestock sector ingested an estimated 6 billion tons of feed in 2010, according to this work. And human edible feed materials represented 14% of the global livestock feed ration. But this figure, this 14%, represents 30% of the global grain production in 2010. The problem is not the cow, but how we feed ruminants. Intensive feedlots account for about 10% of the world's total beef production and about 600 million hectares of the world crop land used to produce feed to animals. Around 70% of the grains used by developed countries are fed to animals. On the other hand, extensive and mixed grazing represent the majority of ruminant production systems, accounting for 90% of worldwide beef production. At grazing, ruminants are part of the carbon cycle. The carbon cycle has three components: plants, soil, and grazers. Plants use carbon dioxide from the atmosphere to grow in a process called photosynthesis. The carbon they absorb from the air becomes part of the plant. Ruminants that feed with plants pass the carbon compounds along the food chain. Most of the carbon the ruminants consume is converted into carbon dioxide and methane, and it is released back into the atmosphere. When animals and plants die, the carbon is returned to the atmosphere as carbon dioxide or retained in the soil by the action of decomposers. When the carbon cycle is imbalanced, carbon dioxide is emitted into the atmosphere, then returned to its sources in an ongoing pattern. However, since the dawn of agriculture thousands of years ago, humans have been disturbing that balance with degenerative farming practices like tilling that kill soil life and release too much carbon dioxide into the air. Rear ruminants at grazing may be the way to reduce the use of edible food consumption by the animals and to reduce greenhouse gas emissions because of the carbon cycle. However, we face here another hot issue. The role of livestock on deforestation is debated because deforestation is a major cause of biodiversity decline and a major source of after carbon fossil is the second major source of greenhouse gases emissions. On the other hand, grasslands are areas dominated by grasses with a low abundance of trees and shrubs, which can be used naturally for grazing purposes. Where can we find natural grasslands areas? Natural grasslands are found in both the tropical region and the temperate regions. And tropical, they are named savannas in Africa, South America. In temperate regions, we can find North American prairies, Eurasian steppes, and South America pampas. The extent is largely climatically determined, occurring where the climate or soils cannot support a woody plant growth. We have natural grassland in the north and in the south hemisphere, as we can see here in the map. Uruguay, my country, is located in a natural grassland area which is known as campos. From the sky, Uruguay can be seen as a large meadow. More than 80% of the land is pasture. We are 3.5 millions of inhabitants and about 12 millions of cattle heads. We have to say. And 75% of the beef production is exported. All the animals are tagged according to the National System for Livestock Information. Why traceability of cattle matters? Traceability of each animal allows to know where the animal was born and all the details about its life until it reached your plate. That system allows consumers to know the origin of the beef meat for health and rear conditions and environmental impacts. Some studies have been conducted to assess the environmental impact of the beef production in Uruguay. I will show now the main results of a study of Picasso for the finishing phase. That means the period between end rearing and slaughter. Depending on the feed availability and quality, animals could be fattened at different average daily gain for longer or shorter periods to reach the final weight. We're going to see fattening on native pastures, fattening on seeded pastures, and fattening in feedlots with diets containing 80% of grain. The study showed that single metrics of sustainability, such as carbon footprint, seem to favor intensive solutions for ruminant production. However, in such solutions, there are trade-offs in relation to other important environmental variables. The grassland system, that means the backgrounding and finishing at grassland, has a maximum carbon footprint and minimum values for all other impacts. On the opposite side, the pasture feedlot system has minimum carbon footprint and maximum values for all other variables. This plot had the advantage that shows the information of all impacts and allows for identifying trade-offs among variables and which variables have more impact on each system. A second dimension is the trade-off between global and local environmental issues. Climate change is a global problem, while soil erosion, pesticide toxicity, and water quality are local problems which must be addressed by local decision makers and cannot be overlooked. The third dimension is the trade-off between carbon footprint and biodiversity. In the livestock systems analyzed in this paper, reducing carbon footprint is associated with increasing the impact on native grassland biodiversity. Finally, the authors suggest that grazing systems have significantly less impact than feedlot systems. This illustrates the importance of choosing carefully and well-founded weights for the environmental variables. Additionally, there is a great potential to improve the productivity of grazing livestock system in the region, without the addition of input, but just improving grazing management. This framework is being followed in Uruguay and the region, with public policies oriented to preserve the natural grasslands and the adaptation of these systems to climate change. On the other hand, perennial pastures are revalued based on the ecosystem service that they can provide. The Millennium Ecosystem Assessment defined ecosystem services as those benefits that people derive from ecosystems. These benefits can be of two types, direct and indirect. Direct benefits are the provision of services such as water, food, the regulation services such as floods, soil degradation, pests and diseases. And direct benefits are related to the functioning of ecosystem processes, such as the photosynthetic process and the formation and storage of organic matter, nutrient cycle, for example. One important ecosystem service is carbon storage in the soil. Grass species store most of their carbon below ground in their root system. And here you can see the importance of storage in native grasslands. Historical land use change is the single largest disturbance of grassland carbon, leading to an estimated global loss of 30 and 50% of the grassland carbon store. Practices such as converting grassland to cropland, draining wetlands, and construction such as urban developments lead to carbon loss. So maintaining soils under grassland cover for grazing purposes allows to conserve carbon in the soil. Ecosystem services also refers to non-material benefits such as aesthetical and cultural values. This study has focused on the impacts of declining livestock numbers on the quality of the landscape. 5 locations representing different landscapes were chosen, covering both the uplands and lowlands in different parts of England. After 30 years without ruminants, distinctive features of the current landscape have disappeared or changed significantly. Besides the effect on biodiversity impacts, there are also changes into the wildlife living in these areas. So grazing can play an important role in contributing to landscape, habitats, and biodiversity, and can prevent the incursion of weeds and other invasive plant species. Finally, this figure summarizes the main challenges that grazing ruminants should face in order to contribute positively to the Sustainable Development Goals. We can mention increase the availability of affordable food, improve nutritional security by animal products, contribute to the local economy and the quality of life of the territories, promote consumer-accepted production systems, increase the resilience of low-input livestock systems, improve animal health and welfare, increase biodiversity. So ruminants will continue to serve a valuable role in sustainable agricultural systems, using land that is too poor or erodible to produce high quality foods, as it has been a characteristic of advanced society for several thousand years. Okay, thank you.
Thank you so much, Laura. This was great and very insightful. I think we have one question here for you, that it says, what roles does climate change play in enteric methane?
Sorry, what role
does climate change play in enteric methane?
What is the role of climate change on enteric methane? This is the question?
Yes,
okay.
This is the question.
I think that it's the opposite. The problem is that enteric methane has an effect on climate change because it is a greenhouse gas. We can say additionally, we can say that climate change will impact on livestock production because the effect of on grassland productions, all the impacts that affect climate will impact on this kind of system, livestock system, because they are open air. I don't know if I have answered the question.
Yeah, thank you, Laura.
Okay.
And now I think we move to Dr. Sofia Rey. She will talk a bit more about the nutritious side of the meat and all these claims that have been talked about also much on the media, especially in the social media. So Sofia, the floor is yours.
Thank you very much. Okay. Please let me know if you can see my screen, if everything is correct. Yes. Can you see me? Is everything all right? Yes? Okay, excellent. Okay, so my name is Sofia Rey. I am a veterinarian, and I'm here to tell you a little bit about the nutritional importance of beef and why grass-fed is best. Veterinarians obviously are specialists on animal health, but we also, at least in Uruguay, have a strong background on food health and food technologies. So we deal with these themes very, daily. Very well. I'm going to tell you a little bit about the nutritional value of meat. So here's a steak. Meat, especially beef meat, has an average of 23% of high quality protein. It's a source of vitamin A and B complex vitamins, contains iron, zinc, phosphorus, selenium, and other minerals, and has a low overall caloric value, which is based on its fat percentage. Mind you, this is an average. We can get higher percentages of protein in better cuts and lower on worse cuts, and the same on its fat percentage. But this is beef as an average. Now, I'm going to focus out of those general concepts. I'm going to focus on two to try to expose why I think that beef especially is much more important to human diet than we might think. Especially with the results of the poll, there was a 71% of those 100 respondents that thought we might be able to skip meat, but I disagree, and I'm going to explain why. So proteins, what are proteins? Proteins are chains of amino acids. You don't have to remember this, but it's basically the building blocks. There are these little molecules called amino acids, and they become more and more complex until they form proteins. And proteins, in change, also get degraded into smaller and smaller bits until their base components, which are amino acids. Amino acids and proteins are everywhere in our system, from muscle to enzymes to cell walls to anything you can imagine. It's made of proteins. So they are essential for us to develop. So the amino acids are the building blocks of cells and enzymes. Without them, we fall apart. Now, there's 21 known amino acids. 9 cannot be created by the human body. Others can in more or less proportion, but 9 have to be consumed. It's necessary. Otherwise, again, we won't function. There are enzymes that we cannot synthesize on our own. Now, There's been a few systems that have been developed in order to, well, categorize proteins and their digestibility, because not all proteins are the same. Animal proteins and vegetable proteins are composed differently with different percentages of amino acids and different ways that the body can or cannot metabolize those amino acids. So this is the digestible and dispensal amino acid score. It's a tool that was developed by the FAO. And what it does is it helps us compare the quality of proteins and amino acids based on the ideal protein. So there's a series of tables. You can find this in the FAO protein report of 2013, where they make a series of tables for each age, infants, adults, with their ideal requirements. And then they take one milligram of the protein they want to check, and they compare it, and they give a coefficient and a proportion from that, okay? So you will see what results they got. Here's a table with a series of different proteins. Maybe you will notice immediately that animal-based proteins are higher, and they have a percentage score of over 100. What does this mean? Is that when compared to the ideal protein that a human should consume, in this case adults, it overvalues. So it means it has even more than what we need, which is excellent in the sense that it can be used to complement diets that are poor in amino acids, because this has so much that you maybe need less, or you can combine it with something that is poorer in its composition, and you will get all the requirements you need. So here's beef. It has a percentage of 111. Compare that to soy protein concentrate. That drops to 98.5. It's still good. It has a good amino acid score, but there's a drastic drop. Soy protein on its own, so not the concentrate, drops to 91. Pea protein is also 91. Chickpeas are 83, and almond is 40. People who are consuming almonds for protein, your body is not absorbing that the way you think it is. So that is worth keeping in mind, that animal-based products, especially beef, will give you higher quality protein in your diet. And the proportion of protein content matters as well. Here you can see from Food Data Central, 100 grams of tenderloin beef versus 100 grams of cooked soybeans. Fat-wise, and even almost calorie-wise, they're very similar, but the protein, tenderloin has double. So if you wanted to get from soy the level of protein that you get from beef, you'd have to consume double. You'd have to consume double the fats and double the calories. Or the other way around, you would consume half the tenderloin to get what you get from soybeans. It's interesting. Now, a second nutrient that I want to focus on is vitamin B12. And vitamin B12 is extremely important, okay? What role does it play in our bodies? Well, it's responsible for the myelin recovering of nerves and neurons, okay? So it's sort of, imagine a cable, it's the rubber edge, like outside of the cable, that's protecting all of the essential transmitters inside. It's also essential for cell replication, for regenerating and generating new cells. And it also helps the development of red blood cells that oxygenate the body. So you can already imagine where it goes if we don't have enough vitamin B12 in our system. The other thing about B12 is that it can only be found naturally in animal sourced foods. No plant contains B12. They may contain other B complex vitamins, which are also very important, but B12 is only in animal products. Here are some examples. So to take it back, the beef tenderloin, right, has per 100 grams, 4.2 micrograms. That is over 170% of your intake of B12. So you satisfy that with 100 grams of tenderloin. Soy has 0. So you can consume as much soya you want. If it's not fortified or supplemented, it does not contain B12. You're not consuming it. And for vegans or vegetarians, some of the answers are fortified cereals or nutritional yeasts. But as you can see, fortified cereals, they're only supplemented up to a certain degree. you can't put 100% of your daily value in cereal, which again, it's worth keeping in mind. This is important because a study in 2003 in the Netherlands showed that obviously there were B12 deficiencies in many vegans who didn't consume any animal proteins at all. But even ovo-lacto-vegetarians were having diminished intakes of B12. So that just shows how much meat, precisely meat, adds to your normal requirements and your overall health. And this is also worth noting. We've been talking mostly about adults. We've been talking mostly about mixed diets or omnivorous diets, but B12, vitamin A, zinc, and iron are responsible for the stunting and undernutrition of 151 million children worldwide. This goes beyond sometimes a choice of, well, will I consume more meat, less meat? Some of these proteins are necessary for the good development of millions of children, millions of unborn, because their mothers are not consuming enough of these nutrients either. And stunting isn't just, a smaller stature, maybe slower cognitive development. These are things that impact generations. Those children that have grown with deficiencies will become adults that have grown with deficiencies and will pass those deficiencies onto their kids. So we're talking long impact that, well, if we managed our animal proteins better, we wouldn't have maybe such a problem. This animal source foods article paper is brilliant. I recommend you read it if you ever have the time. Now, I hope I've been able to persuade you as to why I think meat plays a much bigger role in our diet than we generally presume. And now I want to explain why I think grazing beef meat is better overall than feedlot meat. So feedlot meat, which is the finishing through grains, right, it's been found to be fattier. So it contains more saturated fats, okay, than grazed meat. It has low amounts of vitamin E. And because of this and the fat profile, it generates an inflammatory response in the body. It triggers it because of how the saturated fats are metabolized in the system. This inflammation is at the core responsible for ischemic heart disease, cancer, diabetes. These are the things that we think, oh, the dangers of consuming meat. Well, saturated fats play a big role there. But grazed farmed beef tends to be leaner with a more omega-3 fatty acids, so less saturated fats in their system. They develop high amounts of vitamin E. Vitamin E is an antioxidant, and antioxidants help you shield some of the damage that can be done to your body by the oxidation processes that happen daily through our metabolism. So it generates less inflammation, so it may even decrease some of the health risks that we associate with eating meat. And it's also tastier. It's been theorized that because of all of the different grasses that the animals consume, they all add a little bit to the flavor of the meat. So it might actually even be tastier and more preferred. Additionally, there's reasons to believe that the grazing system might even be good for the cattle, not just for the meat that we're going to consume as end product, right? There's better animal welfare. The animals have spaces to move. They're in their natural habitat, which is the grassland. They are expressing their normal behaviors. They're herding, they're selecting their food. Some systems allow calving, so the calf can be with the mother and not separated and reduce a lot of stress. There is good airflow. There is stimulation, because obviously there are things around for the cows to do. They're very curious animals. Having less animal density means less chance for infectious diseases, less outbreaks, and less outbreaks and less diseases means less antibiotics. less risk of diseases jumping to humans, less zoonosis, and better quality of life for the cattle. And most importantly, if there's something that I want you to get out of this part of the presentation, everything that I've been telling you about has been this. This is when I'm saying meat, when I'm saying all the benefits, when I'm telling you, yes, this might be good for your diet, I'm talking about this kind of meat. I am not talking about this, okay? These are fundamentally very different things. Processed meat is a whole different ballgame, not to mention the amounts that we are consuming. We're not consuming meat equally in the world. And that is maybe what's skewering our ability to think rationally about what it is as a food. And in that same line, I want to talk a little bit about plant-based replacements, okay? Because while we're thinking, oh, okay, there's a lot of health issues that come with eating meat, I'll eat something that doesn't come based of meat. I'll use a plant-based replacement. Well, here's a few things to take into account. This is the nutrition fact for the Impossible Burger, okay? Look at the saturated fat. That's 40%, this is 100 grams, it's about a patty and a half. That's 400% of your daily intake of saturated fat, which we've said is responsible for the inflammation and heart disease and cancer. It has carbs because it's based off potato and soy. Meat does not have carbs. Carbs are sugars. Meat is sugar-free, but these are not, because obviously plants have starch, and starch is a sugar. You get 19 grams of protein, fantastic, but what kind of protein? Soy and potato. Soy, we saw 91% on the DIAS scale. Not bad, but not great either. And this is death knell. 16% of your sodium intake in one patty and a half. That is a lot of sodium. If you consume 4 of those, that's it. You cannot eat any more salt. Worth noting that it has vitamin B12 addition, well, which is something, right? About the same as the tenderloin. Here's another one. This is the Future Farm ground beef. I just want to point out that the typos are theirs on their site. I didn't edit this at all. So the saturated fat is 10%, 10 grams, which is 52% of your daily intake. That is a lot. This is also for 100 grams of ground beef. Look at the sodium, that's 10%. And it also has carbs, the same amount of carbs. What protein does it have? It has soy, pea, and chickpea. We saw chickpea is barely, well, not barely digestible, but when you compare it, it's much, much weaker of a protein. And it has no B12. So you consume this, you may think, oh, it's identical to meat. I'm eating the same thing. No, you're not. You're not consuming the same. You may choose it. The option is yours, but it's not the same. And to close, here's the hottest topic, cultured meat. I recommend you read the article I linked. It's called The Myth of Cultured Meat. I swear we didn't pinch the title. We found it out after we started the masterclass, okay? So it's still obviously a very new technology. It's something that there's a lot of work still to be done, a lot of research to be done, but I want to let you know a little bit where we stand on cultured meat. So it's impossible to reproduce the diversity of meat through cultured meat. Cultured meat stimulates the replication of the muscle cells, which can be modified a little bit. They can be modified with their fat content, what kind of fat they have. But you can't say, oh, I'm going to make chicken out of this. I'm going to make fish out of this, because it's impossible to differentiate them, like to generate different cells. So you can, or you'll say, oh, I'm going to make rump and I'm going to make tenderloin, or I'm going to make, you can't. It's just meat in its most primitive state, I guess. So that is something to keep in mind. Less environmental impact. Well, okay, so we've established that ruminants generate a lot of methane, but the factories or the laboratories that generate cultured meat use fossil fuels. They have to keep the cells warm. They have to obviously they have generators, they have electricity, and CO2 stays in the atmosphere way longer than methane. Worth keeping that in mind. Nutritional value. How can you check exactly the nutritional value of these cells that you are forcibly replicating? How can you be certain that they contain this amount of iron, this amount of zinc, this amount of B12? It's complicated. There are ways that scientists are trying to fine-tune those aspects of cultured meat, but we still don't know for sure exactly how and how much and how consistent you can get the nutritional value. Less cruelty involved. Okay, no slaughter or slaughter-free is usually the motto of the cultured meat. However, there are still animals that have to be biopsied. So the prime cell has to come from somewhere. So an animal, sadly, has to be bothered, at least for that. But also the cells are cultured in bovine fetal serum, because that's the only substance for now that can give the stimulants that the muscle needs to grow appropriately. And in order to do that, well, sadly, you're going to have to sacrifice cows for the serum. Healthier. Well, it can be healthier, I guess, because obviously the meat can't get ill. The meat will get, doesn't have the risks of contamination at the slaughterhouse, but we don't know. These cells are multiplying. We're forcing them to multiply. They don't always multiply the same. That's how cancers are generated when cells start multiplying abnormally. We don't, biology has that thing. We can't really predict it 100% of the time. Sure, maybe we won't have as much antibiotics or modifiers in the cultured meat, but we don't know. What if we start having to apply antibiotics to it so it doesn't get contaminated? What if the growth hormones that we're using to stimulate the generation of this muscle have an impact on us? We just don't know. And last but not least, acceptance. I don't know about you, but if you are a consumer of meat, when you are faced with cultured meat, there's something sort of visceral that pushes you away. You just, well, I'd just rather eat a steak, thank you. That will be the biggest hurdle for cultured meat. We still don't know if it is a viable alternative. It's an interesting technology that is being researched every day, but I also personally don't think it might replace meat in the way that maybe some of these people would wish it did. So yeah, that's a little bit about beef, about meat, about why it's important in our diets, about maybe changing some perceptions about why we should eat meat, what is really dangerous about eating meat, and why grass-fed or grazing systems or pastoral systems that generate beef are, for me, infinitely better than the other alternatives. So once again, thank you very much. And I'll give back the word to Victoria.
Thank you very much, Sophia. This was very insightful. And as you can see on the Q&A, it's full of questions. Yes. This raised a lot of questions because obviously we get a lot of information from the media, from, different reports. And it's like, what is true, what isn't? So I think in the interest of time, we will cover some of the things in my presentation later. We can also, Sophia will also be answering these questions to you. But one of the things is, here, Tamsir asks, how about the myth that beef meat contribute to hypertension and diabetes?
So it's not a myth per se. Obviously, it has fat. Meat is fat. It doesn't matter how much you try to remove the fat from it. There is just fat that grows in between the muscle packages, right? There's different cuts of meat. There's fattier meat. You cannot compare a lean piece of beef with Wagyu, for example, which are the marbled kind of beefs that are made like that. They're chosen to be developed like that. But the fats and the fat profiles, the omega-6 versus omega-3, which I don't want to go into a lot of detail because this is not a biology class, but they will generate reactions to the body. If you consume over the amount that you should consume, you will generate fat in your body. Fat has its own inflammatory effects. It's sort of like a snowball effect. It affects the insulin absorption. So yes, it's not a myth. However, it's not that if you eat one steak, you will get hypertension. It's all about moderation and the quality versus quantity. A lot of times we think, oh yeah, oh, a piece of steak. Yeah, but it's not just a steak, is it? It's a steak and the cheese sauce and the fries and the Coke, and that will definitely give you hypertension, diabetes. There's not to say there is no risk when you eat meat that, yeah, you can develop a chronic disease like that, but it's not instant. We have to be mindful of the way we eat meat.
Thank you very much for your reply. And it's exactly that. It's about the quality. It's about, when we think about meat, many times we think of a burger. We do not think of a tenderloin. That's the difference. We need to differentiate tenderloin from processed beef. But anyways, there is a lot of questions in the chat. Sophia, please take time while my presentation to maybe answer, and Laura too, because there are some for Laura. In the interest of time, I'm going to share my presentation. Okay, let me just look for it. Okay, so for my part of the presentation, what I'm going to talk about is about the technology aspect. I mean, what type of technologies are we using in grazing systems? And why do we need technology? We need technology to feed the world's growing appetite. Even though what you hear in the media, the global meat consumption continues to grow, there is still a lot of demand for beef, pig, poultry, sheep, and this will continue to grow also because the population is growing. But at the same time, we only have one planet, and the areas where we can raise animals are pretty limited. Also, if you consider that right now with climate change and because of areas affected by drought or flood, those areas are all the time becoming smaller. So how can we actually raise more livestock or generate more protein, but with the same type of inputs? We need to improve the production, but with the same amount of land, the same amount of fertilizer. It's not about putting more agrochemicals into the pasture, because this would only contribute to contaminate the rivers. So we have to be very mindful that all the inputs in terms of machinery and feed and land, they have to remain the same, but we need to be able to produce more. And beside all this, there is also the issue that farmers face multiple problems that affect their operations, so we need to help them become more efficient. For example, one of the big problems is livestock theft. This is a huge problem in the whole Latin America and in the whole Africa, which is making farmers not want to raise any more livestock too. And loss due to one, animals that just get lost and then they die and cannot be found. Health monitoring, it is super important to be able to detect the health of the animals, being able to detect right when they are sick so that you can prevent an epidemic from happening, detecting when a cow is giving birth, for example, because if there could be complications, then both the cow and the calf can die. Inefficient grazing or overgrazing, we need to make sure that the small amount of land that we have to for the animals to graze, that has to be optimized to the maximum, but at the same time avoid overgrazing, which can then lead to soil degradation. And in many countries there is lack of traceability, so lack of knowing where the animals have spent all the time. And so for that, we can have some help to help the farmers. We can use technology. And for technology, we can use technology from space, which with all the constellation of satellites that we have right now, these are just a few examples of, for example, Airbus that has Earth observation satellites or radar satellites. The SES, for example, that is an operator of satellite communications. In the rural areas, this is super important because there's no connectivity. So having satellite connectivity is very important. Axel Space is a startup that is doing satellite imagery too. And then we have the geolocation systems such as GPS and Galileo, which are super important to get accurate geolocation in the rural areas. And so I'm going to start with an example, which is my startup, where we use it's Chip Safer. And what we do is we improve the welfare and security of livestock while enabling sustainable farming and providing traceability across the animal's life cycle. And to do that, we have collars, smart collars, that get the GPS location of the animal and get movement traits, send all these to a gateway, an antenna that is placed on the field. And then from the gateway, it goes through satellite connectivity or Wi-Fi to the cloud where the farmer can see all the animals. Here we can see this is the device that gets attached to the collar that goes around the neck of the animal. It is IP67, so it can withstand bumps and all types of and weather conditions, which is something very important because when you are doing technology for the rural area, you need to make sure that this is a technology that will stay there and has to withstand all these rural conditions. Also, it has a GPS and an accelerometer. But you can adapt the transmission rate. You can transmit every 1 minute or every 30 minutes. It's reusable. It has a solar panel, so it can get recharged. Because something very important when you're designing for the farming industry is that you cannot herd the animals all the time. Many times you herd the animals maybe 3 times per year. So you need to make sure that anything that you place that an animal is going to wear, being an ear tag, being any type of device, you need to make sure that it's something that is going to stay there because you're not going to be able to take it out and plug it into the grid. And it also, if you have a lot of animals and you want to detect an animal that is sick, you can just send a command to remotely activate an LED and identify that animal very easily. We also have a software. It's very important. So for the farmers right now, many, they still use a notebook. And so it's nice to move the industry, to digitalize the farming industry and have all these records online, which can make so much easier for the better management of the herd. And also to get alerts if there is a problem and take very fast action, as well as having the whole traceability of the animals. And also, it's not just about using one technology, but using many. For example, here we can correlate the data from the sensors that the animals wear with satellite imagery. And with the satellite imagery, we can know if an area is, for example, overgrazed. And in that case, we can say, okay, you can move the animals to another area and leave this area to regenerate. So you give enough time for the soil to regenerate by itself and not get degraded. And as I was saying, the really important thing is having the whole traceability, being able to know everything from when the animal is born until the cat gets to the supermarket, that you as a consumer can have the ability to know if that livestock contributed to deforestation or not. As Laura was saying in the beginning, if you have livestock grazing in areas like Uruguay or Argentina, this is really good for the environment. Of course, then you have some areas in the Amazon region in which what happens is the cattle laundering. What happens is some farmers have legal land, but they also take the animals to graze at illegal areas. And you never know because the farmer says that they are in their legal lands and you do not know that but this is just a few farmers. And so what is nice to have this whole traceability and this whole transparency in the food chain is knowing which are the bad farmers and which are the really sustainable ones, and really highlighting those sustainable ones that really wants to make sure that the land is good and that they want to have a positive impact, and there's a lot of them. So this is a really good way for the for the consumer to really understand, have power on their decisions, and really get beef that comes from sustainable farming. Here, also, I want to show very quickly other examples of other technologies that are already in use by farmers. One of them is, for example, on the top, it's an ear tag. This ear tag is from a company called Quantified Ag. You can put it inside of the ear and it gives you health traits from the animals. Also, if an animal is sick, it activates an LED, and so you can easily find it. Another type of sensor is a bolus sensor. This goes inside of the animal in the intraruminal area and can get you health trait. It can detect estrous cycles, so when the animal is in heat, and also it can detect temperature of the animal. Also, you can use your phone. Now there is a company called AgroNinja in which you add a camera to your phone, and you can take a picture of a cow in the middle of the field and detect their weight, which is very important because generally you have to herd all the animals. It takes a lot of time, and then make them pass through a scale. With this, just with a phone, you can know the weight, which can save a lot of time. Also, there are sensors that can be placed on the tail of the cow. This is important for what I was saying of detecting when a cow is giving birth. That is super important in order, if there are complications, that you can go and help the cow and the calf, of course. In the middle, there is this sensor. It's from a company in Australia called AgriSense. It's a collar, and it's a collar that does not only have the GPS, but also has control. It can control where the herd goes. So it has these virtual fences in which if the animal goes to a specific location, then a sound comes up, and so the animal does not trespass that fence, that does not trespass that area, which is very important for when you do not want to have a fence that many times in places like Australia, for example, it's too big, so you cannot have that many fences. And then, of course, you can also place cameras, that can detect movement and that can detect, for example, if you detect that an animal is getting stolen, just if you have the cameras in very specific areas around the farm, you can just get an image of what's going on. Of course, correlating all this data with weather imagery, with weather information, it's super important. Farmers really need this weather information, especially with all the climate change going on, to forecast how the next season is going to be. Make sure that they have enough irrigation, make sure that they are prepared for a drought or for a flooding. So weather is not just about knowing when it's going to drizzle or being prepared for a tornado, but also being prepared for next seasons. Also, satellite imagery, as I was saying before, it's about detecting change. Here, this is a company called Axel Space that provides satellite imagery, and you can see the change detection. You can also be able to monitor forestry, because it is important, as I was saying, in the Amazon region, making sure that there is no deforestation due to illegal grazing, and also being able to monitor the water resources, which is super important. We want to make sure that the whole ecosystem is sustainable. And many times you cannot have a satellite image because of the revisit times of the satellites or because of the clouds. And for that, a drone imagery is pretty good too. Or for example, if you have a problem with a specific cow and you know the location of the animal, you can just send a drone, take an image, and if you're too far away, and detect if it's a problem or if it's or what can it be. And also, a lot has been talked about the carbon sequestration, as Laura was saying. And one of the things that you have to be in consideration when you talk about what is the actual carbon sequestration of the farm, if a farm is emitting or sequestrating carbon, is there is not just one measurement. You need to measure the vegetation, how much vegetation there is and what type of vegetation there is. You need to check the pasture. Is the pasture degraded? Is the pasture okay? What is the quality of the pasture? Get soil samples. Be able to see how much the soil is sequestrating of carbon. And with that, you can do a whole ecosystem assessment to know if this farm is sustainable or not. But you cannot just take one data and say, okay, this is sustainable or not. You need to consider the entire ecosystem. And here also, you know, about the welfare of the animals. This is a robotic farm in Uruguay in which the animals, these are dairy cows. The cows, they are grazing around happily. And when they want to get milk, they just go to the milking parlor. A sensor, a reader reads their ear tag, and they get milked, and while they are eating too, and then they go out. So this is very for the welfare of the animals is much better than the other systems. And what is the future going? This is something that I saw in 2015 at the University of Tokyo, and I thought it was super good, and I think that that's the future, which is kind of a sensor that you can put in. It's kind of like a tattoo. So I think that in the future, the animals, they ask me all the time, can you do a system that that goes inside of the animal that is a very small chip that is like a tattoo? And the answer is probably yes. The problem is the price. And this is one of the things that I wanted to talk about last. That is, right now, the farmers really do embrace technology. They really want to become more sustainable. I met farmers from all over the world, and they all say the same thing, that they want to use technology. The problem is that the margins that they are doing are pretty small, and the technology is still at a point in which it's a bit expensive. So right now there is this dysfunction in terms of how much the technology is cost and how much the farmers can pay. So that's why we need more financing options. Now there are some financing options that it's getting better, but still we need a lot more financing options to help the farmers become more sustainable. You know, let's just not demand people to be sustainable, but also help them with financial tools. And finally, just to finish, as I was saying, I think that there is not one right solution for the farming industry and to help more efficient, but it's a combination of all the solutions. It's Internet of Things sensors, it's drones, it's satellite imagery, it's you know, sensors, weather stations, all types of technology that you can bring into the farm. It's going to make the whole system more sustainable, and it's going to improve the productivity and help in the animal welfare. And so thank you very much, everyone. And I couldn't see the Q&As yet, but I think that Sophia has been and Laura have been answering a lot of the questions. So in the interest of time, I think we're 7 minutes past. I think that Laura or Sophia, if you want to add any additional last thoughts.
Well, I once again want to thank the organizers for inviting us to this masterclass. I think it's a very good opportunity. You know, all three of us were Uruguayan. The Uruguayan consumption of meat is, you know, we're not a very good example in the whole eat quantity and quality. Well, I guess we do both, but we do love to consume meat. It's part of our culture. So it's something that I think we're very proud of. It's a very cultural identity as well. And we wanted to explain, I guess, as you know, more than just why we enjoy it more than just the food. There's a lot that goes behind it, and
yes, I think Sophia is talking about culture values. That it's another if you want an ecosystem services also from these landscapes. I just because I was seeing the questions, and just to say that I think that this presentation has the main objective to try to think out of the box, if we can say. So to have a larger approach to the myth of meat, and to see that the problem is more complex than only to think about carbon footprint or just land area occupied by production. Just that. Thank you. And thank you to the organizers. And thank you to you, Victoria.
Yes, thank you very much.
Coordination.
Fantastic. So thank you so much to everyone that has attended. Oh, just one last thing that I forgot. So Davide, if you want to do the poll, just to see if after all this, there is a bit of change to what we see on social media. Okay, so there you have the poll. You can answer all those questions, and then we see, and then we wrap up.
Just keep in mind there's 5 questions, so they will show up one after the other.
Okay, fantastic.
So we already see a very big difference.
Yes, we see a big difference, which that is great. No said 81%. The next question, Davide? This is great. We're going at 93%. That is fantastic. And then, Davide, maybe the next question. This one is the one that got the most amount of questions, the one that was the most
very 50-50.
Controversial.
Yeah.
Controversial one. So let's see what they say. Okay, this is still a bit, but so I think, but so yes, we see that there has been some differences. So anyways, thank you to everyone. It's been great to share all this. Sorry, were the results being shared public, or were we only seeing it? Davide? Davide, are you there?
Yes, we still have 2 more questions to share.
Okay, but I mean they were being broadcasted, right? I mean everybody can see the polls.
Yeah, they are voting. Actually.
Okay. But I mean everybody can see the results, correct?
Yes.
Okay, perfect. Okay, so humans do need. This is great. We also had a better answer here, and so I think that the last question, well, is more about the technology that was already we knew. So I think that that for now we thank you very much to everyone that joined. I hope you enjoyed the content. Thank you very much for all the messages in the chat. Thank you so much to the organizers, the World Food Forum, and all the team for all the support, and especially to Laura and Sofia. This has been very insightful. So thank you very much, and enjoy the rest of your day, everyone. Bye-bye.
Bye-bye.
Bye, everybody. Thank you once again.